This is very interesting. AI as we know it today wouldn't have existed before the year 2017. That was the year something very important happened which shaped the industry and research drastically. But before we get into exactly what happened, I want to provide you with a context so you can fully understand why this innovation was so impactful. So let's look at the history of AI first. There are several approaches to AI, but the one which is widely used today is called connectivism. This was first formulated in 1943, and the design of a neural network was inspired by the human brain. The neural network consists of units which are connected to each other, just like neurons in our brain are connected by synapses. And when the neurons are activated, they send signals to neighboring neurons. Based on this principle, the very first learnable application was created in 1958, and it was called the perceptron. So let me give you an example how this works. Imagine that you want to learn soccer, and the first thing you want to practice is scoring a goal. You place the ball in front of the goal and you kick it. And you can see that it doesn't reach the goal line. That means that the force was too small. So the next time you try, you slightly increase the force. After several iterations, you find the threshold, such that whenever you kick the ball with more power, you always score. And this is exactly the idea behind the perceptron. So the perceptron expects an input, in our case is the force, and it passes the input to the single learnable neuron. You can imagine that this neuron is a memory which can store some information. After this neuron processes the input, it results in a single value which is then compared to a threshold. If that value crosses the threshold, it means that the prediction is positive. In our case, we score the goal. And if it doesn't cross the threshold, it means that the prediction is negative, so we missed. And if the prediction is wrong, the learnable neuron updates its memory. This perceptron was a huge success, but shortly after that, researchers found that this simple network can solve only a limited subset of problems. And to solve more complex and harder problems, we would need to have more layers of neurons, which was called multi-layered perceptron. But back then, nobody knew how to train such models. Therefore, a period known as the AI winter started, and it lasted for almost 2 decades. Fortunately, this changed in 1986 when scientists came up with an idea how to train these models. This method is called backpropagation, and basically it means that we can now know which neurons are responsible for bad signals, and we know how to update their memory during training. This breakthrough allowed researchers to create more advanced neural network architectures. Some were used for image processing and some other were tailored for language. The first widely used architecture for language processing was recurrent neural network, or shortly RNN. These networks processed the input as we do. They read word by word and update their memory along the way. However, these neural networks had one big flaw. I am guessing that some of you love reading books. I also do. And maybe also some of you struggle with finding enough time for reading the books. Instead of reading for 15 minutes once a week, you want to read for 15 minutes every single day. Essentially, the more books you want to read, the more time you need to spend. And this was the exact same for recurrent neural networks. They weren't scalable because they couldn't read more than one word at a time. Then finally, in 2017, Google published one paper which introduced a new architecture called a transformer. This architecture allowed for parallel processing. So instead of reading a book word by word, imagine you could look at the page and scan every word at exact same time. And this is exactly how transformer works. And this is the reason why GPUs are so widely used for AI, because they were made for parallel processing. So this is why the data centers are so massive, because the more GPU power you have, the larger models you can train and run. If you want to know more about how AI works, watch this video where I explain how words become numbers. Thank you very much for watching and see you in the next video. Bye!